You know when you see one of those huge, stunning LED displays? You're just seeing the beautiful image, right? But the real story, the thing that makes it all work, from how long it lasts to how perfect the picture is happening with tiny, invisible tech inside. So that's what we're going to do today. We're diving deep into the hidden world of pixels. Okay, so you've probably seen these acronyms flying around: SMD, COB, IMD, MIP, and it's easy to think, are these just random letters? But here's the thing. They're not. Each one is a totally different way of building an LED screen. And figuring out what they mean, that's the secret to actually picking the perfect display for what you need. All right, let's kick things off with the one you'll see most often, SMD. That stands for Surface Mount Device. Now you might think, okay, the most common one, probably pretty basic. But even right here, there's a huge difference between the old way and the new way of putting these pixels together. And trust me, it completely changes how reliable they are.
Just look at this. The difference is night and day. On the left, that's the old school conventional SMD. You see those tiny, delicate little gold wires? Those are what connect the chip. Now look at the right. That's the full flip chip. Big difference, right? The chip is literally flipped over and mounted directly. No more wires, just a solid, strong connection.
So, what's the big deal about getting rid of those little wires? Well, it's a huge deal. Think about it. With the old way, those wires are the #1 thing to break. Plus, they literally get in the way and block some of the light. With the flip chip, you solve both problems. You get a connection that's way more stable and a pixel that's way brighter. So if you're, say, a business owner, that means your outdoor sign is going to be way more visible, even in bright sunlight. And it's just not going to fail as often. Okay, so let's boil it down. The full flip chip gives you 3 massive wins. 1, higher stability because there are no wires to snap. 2, it's way brighter. We're talking up to 2,000 nits compared to maybe 800 for the old style. And 3, it runs cooler. That direct connection to metal means heat gets pulled away much better, so the whole thing just lasts longer. And here's the secret sauce for how it's so efficient. It's all about something called a common cathode design. So instead of just blasting one big, wasteful stream of power to all 3 colors at once, it's smarter. It sends a specific, precise amount of voltage to the red, a different amount to the green, and another to the blue. It's like giving each one exactly what it needs and nothing more. The result? No wasted energy, less heat, and way lower power bills. Over the long run, that's real money you're saving. It's just a genius way to power a pixel.
All right, next up, let's talk about our second contender, COB, which stands for Chip on Board. Now, this isn't just a small step forward from SMD. It's a whole different way of thinking. See, instead of building with individual little pixels, COB is all about creating one smooth, seamless canvas.
And you can totally see what I mean right here. The little LED strips are put right onto the circuit board, and then the whole thing is covered with a layer of resin. What you get is something called a surface light source. It's totally flat, totally smooth, no little gaps or bumps between pixels. This makes it way more comfortable to look at. It's just so much easier on your eyes. And that special design? It gives COB some really killer advantages. First off, it's super stable. But that resin surface, that makes it incredibly tough. I mean, we're talking waterproof, dustproof, and you can even bump into it without a problem. You can literally just wipe it clean. In a busy place where things happen, that means way less stress and lower maintenance costs. Okay, now we're getting to the really cutting-edge stuff. This is the battle for the tiniest, most detailed displays out there. And in this arena, we've got 2 main fighters, an established player, IMD, and the new challenger, MIP. So first, let's look at IMD. That's Integrated Matrix Device. The whole idea here is to bundle a few pixels together, usually 2 or 4, into one little package. People call it 4-in-1 or 2-in-1. It basically makes it easier to manufacture screens with really small pixels. But it's not perfect. IMD has a few drawbacks. Because you're clumping pixels together in these little packages, the final image can sometimes look a little bit grainy or inconsistent. Plus, people have pointed out that they can use a lot of power and get pretty hot. And that is exactly why MIP was created. MIP stands for Micro LED in Package, and it was engineered from the ground up to solve the exact problems we just talked about with IMD. And check this out, because this is one of its biggest game changers. Instead of grouping pixels together, MIP technology lets engineers sort every single pixel individually. So every tiny little light is tested for its exact color and brightness before it ever goes on the board. And the result? Just incredible color consistency across the whole screen. That graininess problem? Gone. The color uniformity problem? Totally solved.
And what's really cool is that this perfect uniformity leads to a perfect viewing experience from literally any angle. I'm talking a full 360-degree view with zero dead spots, zero color shifting. Imagine you're in a broadcast studio or a mission control room. That kind of consistency isn't just nice to have, it's essential. It means that no matter where you are in the room, you're seeing the exact same flawless image as everyone else.
So you can basically think of MIP as the best of all worlds. It takes that super stable and efficient common cathode flip chip design we talked about earlier. It adds its own amazing pixel-by-pixel color sorting for that perfect picture. Then it borrows from COB by adding a tough surface treatment for protection. And it packs all of that into a teeny tiny package that's perfect for those super high-resolution screens. Whew, okay, that was a lot of tech. So the big question is, how on earth do you choose the right one? Well, let's make it easy. We're going to break down exactly where each of these technologies shines. Let's start with SMD. If you just need a solid, reliable screen for standard indoor or outdoor use and you're keeping an eye on the budget, a good full flip chip SMD is your answer. It's the industry's workhorse for a reason. It just works and it gives you great value. Now, what about Cobb? This is what you want for those fancy indoor spots where people might actually get up close and personal with the screen. Think of a big corporate lobby, an interactive display in a museum, or a high-end retail store. Cobb is tough, seamless, and has that premium look you need to really wow people. And finally, MIP. This is for the big leagues, the places where perfection isn't just wanted, it's required. We're talking broadcast studios where they're on camera, command centers where lives are on the line, or boardrooms where huge deals are made. In those places, the absolute color perfection and perfect viewing angles of MIP are frankly non-negotiable. It's the only choice. So let's put it all in one simple chart to wrap it up. For everyday stuff, SMD gives you great stability and value. For busy, high-traffic indoor spots, COB is your go-to for comfort and toughness. And when it absolutely has to be perfect, MIP is where you turn for color perfection. You know, when you think about it, we've gone from fragile little wires to sorting individual pixels in just a few years. The technology is moving so fast. It really makes you wonder, as all these amazing ideas keep getting better and blending together, what are the screens of the future gonna look like? How perfect can they get?